Learning Target 10 says I can calculate arithmetic sums using Gauss's method. So Gauss's method only works for arithmetic sums, which means that as we go from one number in the sum to the next number, sort of as we go throughout the sum, we keep adding the same number each time. So in this case, as you go from one number to the next, we are adding by 4 each time. So it is arithmetic, and we can use Gauss's method. So the first thing we're going to do in Gauss's method is list out the entire sum. So I'm going to write S equals, where S stands for the value of my sum, 7 plus 11 plus 15 all the way up to 47. Now, when you see a little plus dot 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 like this, what that means is that the sum continues on in between the 15 and the 47, but it's just sort of so many numbers that we say, okay, you get the idea of the pattern. I'm not going to write out every single number, but you sort of get the idea that we keep going up by 4s between 7 and 47. So we sort of use this as shorthand so that we don't have to write out every single number in the sum. So this is our sum. Now in Gauss's method, what we're going to do is we're going to now write out the sum again, but we're going to switch the order of the terms in the sum. So instead of going from 7 up to 47, we're going to go from 47 down to 7. So this requires a little bit of thought, sort of how we fill in the next number here. So if the last number is 47, and if we added 4 to some number to get 47, then the number that comes right before the 47 here must be 43. So our next number will be 43. Similarly, the one before that, we would have had to add 4 to that number to get 43, so the number before that must have been 39. And we know that we're going to keep going sort of down the sum backward until our very last term, which is going to be 7. So the next thing that we're going to do is we're going to add both the left and the right-hand sides of this equation. Now on the left-hand side I have s plus s, that makes 2s. Now on the right-hand side, if you look at sort of these pairs of numbers that we're adding up, if you look carefully each time, if you've done Gauss's method correctly, each time they should add up to the same number. So in this case, 7 plus 47 makes 54, 11 plus 43 makes 54, 15 plus 39 makes 54. So basically what we end up getting is we get a sum of a bunch of 54s. Now if we knew how many 54s there were, we could just take 54 times however many 54s there are, and that would give us the right-hand side of the sum, and we'd be able to solve for the value of the sum itself, which is s. So we need to think about how we can figure out, well, how many 54s are there? And the answer to that question is basically how many terms were there in the original sum, because you can see that for each 54 it sort of corresponds to a single number in the original sum. So we need to think about how many numbers there were in the original sum. So to figure out how many 54s there were, our strategy was we took the last term, subtracted off the first term, divided by the common difference, which is the number that you're going up by each time, so that's 4. Now, what this does is it tells us, well, how many times did we go up by 4? So if you subtract 47 minus 7, you sort of know how much did you have to go up by to get from 7 to 47. And then if you divide by 4, that tells you, well, how many times did you add 4? The issue is that when you do this, going from 7 to 11, you add 4 once, but there's actually 2 numbers there. So this number here only tells us how many times we go up by 4. It doesn't include the very first term, because we didn't have to add 4 in order to get the 7 in the first place. So this only gives us how many times we added 4. It does not include the very first number, the 7, so we have to then add 1 on at the end. So if we actually do this, we get 40 over 4 plus 1, so we get 10 plus 1, which is 11. So we know that there are 11 terms in the sum, and therefore there are 11 54s. So what we can do is we can rewrite the right-hand side of our equation as 54 times 11, because we know that there are 54 11s. And then to solve for our sum s, we're then just going to have to divide by 2. So to figure this out, you're probably going to need a calculator. So if you type into your calculator 54 times 11 divided by 2, that's going to be your final sum. And I got 297. So let's now try another example problem. So in our next problem, we have this sum, and we're trying to find the sum using Gauss's method. So let's start out by writing our sum. So the next step in Gauss's method is that we want to take our sum and we want to rewrite the terms going in the opposite order. So we're going to write s equals 18 plus. Now in our original sum we can see that each time we're going up by 3. So the number that would have come before the 18 in our original sum would have been a 15, and the next term would have been a 12. And so then we're going to keep going down by 3 in this sum and end up at the -6. So the next thing that we have to do in Gauss's method is we need to add down. So on the left-hand side we get 2s because we have s plus s. On the right-hand side we're going to add up all these pairs of numbers, and if we've done everything correctly so far they should all add up to the same thing. So -6 plus 18 is 12. -3 plus 15 is 12, 0 plus 12 is 12, 18 plus -6 is also 12. So what we need to do now is think about, well, how many 12s are there? So to figure out how many 12s there are, we're going to take our last term, 18, and subtract off the first term, which was -6. We're going to divide by the common difference now, which is 3. Now once again, this ends up telling us how many times did we go up by 3 in our sum, how many times did we add 3, but it doesn't include the very first term, the -6. It doesn't count for that because we didn't have to add 3 to get to it. So after we do this, we need to add on 1. So if we simplify this a bit, 18 minus a -6 is the same thing as 18 plus 6, which is 24. 24 divided by 3 is 8, so we get 8 plus 1, which is 9. So there are 9 terms in our original sum and 9 12s in the sum that we have right now. So on the right-hand side of our equation, we can write this, instead of being a bunch of 12 summing up, we can write this as 12 times 9. And then solving for our sum s, we get 12 times 9 divided by 2. And if you actually multiply and divide this out, you should get 54. So let's quickly review the steps of Gauss's method. The first thing we're going to do is write out all the terms as a sum, and I like to say that that's equal to some variable. I usually use s. Then I take the terms of the sum and I rewrite them just in the opposite order. That's also equal to s. You know, you're not changing the sum itself. You're just changing the order that you write the terms. Next thing you do in Gauss's method is you add down on each side of the equation. On the left, you'll have s plus s, which makes 2s. On the right, each time that you add each of these pairs of numbers, you should end up getting the same thing each time. To figure out how many 12s in this case, or how many of whatever other number you get, you can take the last term, subtract off the first term, divide by the common difference, and add 1. That tells you how many terms there are in the original sum, and therefore how many 12s you end up getting here, or whatever other number you get. So then you can rewrite this sum as being, you know, the number that you have here, 12 times whatever the number of terms was. And then you can divide both sides of this equation by 2 to get s by itself. And then you can just simplify down.